assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we have a question about the electron configuration of different ions. And of course, anytime you're doing electron configuration, you want to make sure to have your periodic table nearby. That way you can locate the elements and therefore determine how their electrons are arranged. All right, so let's start. We have 4 parts to this problem. So the first part asks us to identify the electron configuration, or the element rather, of an atom that has the electron configuration of 1s2, 2s2, 2p6 when that element is an ion. Now, it's first important to remember that when you see a 3 positive, that means that it has lost 3 electrons, okay? So electrons are negative, therefore when an atom loses them, it makes it more positive overall. So what we need to do is we need to go to the end of our electron configuration and add back the last 3 electrons. That way we can figure out what the element is. So we know when we're doing our electron configuration, it goes 1s2, 2s2, 2p6, then we would go to 3s2, and finally 3p1. So if we look on the periodic table, this would identify the element as aluminum. So that means the original configuration was aluminum 3+. All right, now let's go to the second part of the problem, which tells us that we have another 3+ ion this time with an electron configuration of Ar and 3d3. All right, so again, just like before, this means it's lost 3 electrons, so we need to add 3 electrons back. Now, the important thing to remember is that when electrons are taken away, they get taken out of the highest energy level. So here, because it's saying 3d, that tells me that this element is located on the 4th energy level. And because it's on the 4th energy level, that means that we'll be removing the 4s electrons before we take away those in the 3d, okay? So what this means is I need to add back the 2 electrons in the 4s, then I would add back the 3rd electron into that 3d area as well. So that means if I look at 4s2, 3d4, that element would be chromium. So this is really a chromium +3 ion. Now finally, let's go to part C, where we have a 2+ ion with the configuration of krypton as the noble gas core, 5s2, 4d10. So in this case, instead of losing 3 electrons, it's only lost 2. We do have the 5s completely full, so that must have meant that it had some electrons in the 5p that it could have lost instead. So those 2 electrons must have been 5p2. So if we look on our periodic table and find that element, that would tell us that it's 10. So this is a 10 2+ ion. All right. Then finally, let's do our last example, which is a 1+ ion, meaning it's lost 1 electron. We have krypton and then 4d10. So again, we know that this element, because it has some 4d electrons, must be located on the 5th period of the periodic table. Again, it will tend to lose its 5s electrons rather than the 4d because 5 is a higher energy level than 4. So this means it must have lost its 5s1 electron, okay? Now we also have to take care here because if it only had one 5s electron to lose, that means that the second 5s electron must have been donated into that 4d subshell to make it full. So instead of being mercury, instead of being cadmium, which is kind of 4d10 on its own, this is more than likely silver. And that's because silver's electron configuration, instead of being 5s2, 4d9, we know that one of the electrons goes from the 5s to the 4d to make it 5s1, 4d10. It's kind